Hi, good evening, everyone. So welcome to our March webinar session that we have on today. And I am super excited to present Mohammed Al-Karousi, who's going to be speaking to us today. One of the requests that we had that have come in from the community has been around cybersecurity, and obviously delving a little deeper into that topic. And as we all know, this is clearly a risk that regardless of what industry we are all operating in, and even what kind of risk departments we are in, cybersecurity is something that affects each and every single one of us. And so I think in this case, information is absolutely key, and knowledge is really powerful in this area. And so whatever we can do to better equip and enable ourselves as risk professionals in this area is really important. So as I said, Mohammed Al-Karousi joins us today. He is one of the security architects at Oman. He is an individual who's probably got over 8 years of experience, is a cybersecurity assessor across sort of public, aviation, and the telecommunication sector. He's a very humble individual, so he probably won't, really boast about all that he's done and his achievements and everything, but he's also an extremely knowledgeable person, specifically in this area, and I think probably working in an industry where, security is of utmost importance and something that, it keeps him busy on a daily basis. So we're going to talk about the risks of the digital attack surface, and I think a few more other areas. So I'll allow him to introduce the topic and himself in a little more detail. But Mohammed, thank you. Welcome. We really appreciate your time this evening. And just in terms of a little bit of housekeeping, as always, I know everybody is just on listening mode now. Please, if you've got any questions, just jot them into the question section, and we will leave some time for Q&A at the end. So we will get to as many of your questions as possible. And without that, we will probably record the session, and we will post it onto the LinkedIn page and things as well. So you are able to go back and reference any of the things that are discussed this evening. But looking forward to a fruitful discussion. So thanks, Mohammed. You can take it away.
Thank you, Kara, for the great introduction. And thank you, everybody, for attending this webinar. As Kara says, I'm really humbled on this sector. However, I wish you get some informations about risk attack of digital attack surface. And let's start. I think I need to turn my camera off to just avoid any delays. So basically today we will talk about risk of digital attack surface. We would go through giving a brief about what is digital attack surface, and then we will talk about the most common attack vectors per attack surface. Then we'll talk deeply into each and every attack surfaces. What's the attack vectors? What are the lessons I learned through 8 years career? And then I did some cyber breach case studies for 3 very famous cyber breaches around the world, and hopefully we'll hear from you some questions about what we present here today. So what is digital attack surface? Simply, digital attack surface is the entire digital environment elements that may be targeted by cyber attacks. It could be a website, it could be a mobile application, it could be a laptop somewhere, mobile phone, a server somehow, printer, any elements, any assets on the digital environment that can be targeted by attackers, considered as digital attack surface. So what's the most common attack surfaces or attack vectors uh, on digital attack surfaces. Let's start one by one, then we will go deeply into each and every type of it. First, on IT environment, internal IT network considered as the largest attack surface with too many attack vectors on internal IT networks. And later on, we will go through each and every attack vectors on internal IT networks. Second attack surface is wireless networks. Nowadays, lots of networks are wirelessly and lots of services can be accessible wirelessly, not only on IT level, even on IoT, even smart buildings using wireless networks. So it's very wide area also. Public interfaces, what we mean by that, it could be anything facing the public, either over the internet or you can find it publicly in smart cities, for example, malls, airports, hospitals, any digital elements facing publics, and it can be accessible from outside the border of the organization itself. And I added two very important attack surfaces outside the digital environment, which is physical security. Uh, I added it because it is very important to understand the physical security and threats associated with non-controlled physical security. And the last one, but the most important attack surface that affect everything and everybody, which is human attack surface. Uh, a digital environment is used by human, and each and every decision made by a human being could affect the digital environment. So I added it because it's very important, and we will see later on why human attack surface is the most important attack surface ever. So on the internal IT network, there are many attack vectors. And when we say attack vectors here, we means by the vulnerability or the weaknesses can be utilized by attacker to either hack the organization, sabotage the networks or digital environment elements, or steal things, data, steal money, etc. Even it can reach up to the level of physically harming the employees and affecting their health or even affect the environment. So let's start one by one. Security architecture. Each and every network must have a security architecture. Simply, it has to have architecture at its first place. But with cyber security emerging, security architecture came into the picture, which means any network has to be designed in a security manner. Previously, networks network designers were focusing on getting the operations, getting the work done. But nowadays, we don't just focus on operation. Yes, operation is important, but we have to do the business in a security matter. Second element is asset management. Now, in security, we have two types of assets. We have known assets, we have unknown assets, and we have uncontrolled assets. So without having a proper asset management, we cannot secure what we don't know. We cannot secure what we cannot manage. So we must have a proper asset management, and to start having asset management, you must have an asset inventory. You have to build inventory about your assets. You must know what you have, what you are managing, what you cannot manage. So, for example, of having asset inventory, you know that there are 3,000 employees on your organization, for example, and you know that those 3,000 employees have 3,000 laptops. But for example, you don't know that these 3,000 laptops have 10,000 applications, for example. You only recorded 5,000 applications and you miss other 5,000 applications. So for for instance, you can manage those 5,000, you can monitor it, but what about those 5,000 you don't know about? How you are going to secure it? How you going to protect the organization network from misusing these 5,000 applications? The other most important element is batch management. Batch management could be targeting the servers in your organization, laptops, it could even reach printers, applications, mobile phone, whatever digital asset associated to your internal network should be attached to batch management process and framework your organization have. Platform security, we're also talking about uh, having a proper security for your platforms. Endpoint security, you must have antiviruses, anti-malwares, anti-spywares, EDR in place, XDR, for example, and you you must have a proper control over your endpoints security in a manner that employees or your staff cannot disable or uninstall these endpoint security from their uh, instances, because if they have that authority, I'm sure they will use it and they will make their devices vulnerable, because sometimes endpoint security annoy people. Sometimes it won't allow them to visit certain websites. It won't allow them to open certain extensions. For example, .exe, they will not be able to run it. They will not be able to open some sort of document that have macro enabled on it. So if they had the power to disable endpoint security, believe me, they will tend to, and they will disable it. SIM solution are important element to protect your internal networks. Simply through the SIM solutions, you can monitor your entire organization, what's going on the organization. You can monitor the traffic of the devices associated with your networks. And even you can see if there's any sort of attacks going on against the organization. Shadow IT. If you remember, I talk about known assets and unknown assets, and unmanaged assets. So what is shadow IT? Shadow IT is simply, it's either unknown assets or it is unmanaged assets. So let's take, for example, Kara, for example, she brought her new laptop to the organization and she didn't talk to the right security people, security teams, and she did not inform them that she brought her device into the organization and somehow she attached her laptop to the organization internal network, and that's it. She started working. Nobody knows about this new device. Neither security team knows about it, or IT people, they don't know about it. And somebody else brought his mobile phone, and he connected to the Wi-Fi network, and he started using his the organization's assets, maybe opening emails through his mobile phone without informing anybody. And somehow the organization did not detect this new device on the organization. This is what we call it shadow IT. Wireless network, it has many elements. Let's take it one by one. Authentication is the most important on any network, whether it was wireless network or wired network. But why we focus on authentication in wireless network? Because you can target authentication in wireless network without even entering the building of that organization and without attaching your device to that organization. You don't need any wires, nothing. You maybe uh, come across the building and park your car outside the building. You start sniff the network. You found some wireless network available around the building. You try to authenticate to it. You try to brute force it. So it is really important how you configure the authentication for your wireless network. And it's really important to raise the awareness among your staff how to authenticate to these networks. What are the wrong practices? What are the right practices? How they can spot the wrong access points, when they should stop, when they should report abnormal activities, abnormal issues they saw, abnormal uh, incidents they saw. So most of wireless network around the world are either authenticated using username or password, or through NAC solutions, or through MAC filtering. It's this or other type of authentications. So as I said, it is important, and I would recommend that organizations should never rely on one type of authentication. What do we mean by that? The organization should never rely on pre-shared key, for example. What is pre-shared key? Pre-shared key is that the network having the same password, and that password is shared across all employees. To access this network, you have to use this shared key. Instead, the organization should use enterprise authentication, where every employee have his own username and password, and that username and password is linked with the organization Active Directory, for example. And also, even this type of authentication should be associated with OTP, one-time password, or should go through MAC filterings or filtering or NAC solutions. The other attack vector on wireless network is rogue access point. If we go back to authentication, we talk about authentication through username and password and through NAC solutions. Now, how NAC solutions can identify that Muhammad, Suzanne, or anybody else is a legitimate user and he should get access to that organization? Most of network access controls depends on two things. One, authentication through username and password, and the second thing through collecting the MAC address. What would happen here? that when anybody authenticates through his username and password, his device MAC address would be sent to the network access control, and it would say this user used a legitimate username and password, give him access. So the attacker understand the whole scenario, what's gonna happen. So they start doing what we call it rogue access point. They simply mimic the same wireless network SSIDs, same name. Let's take, for example, if we say Omantel have a wireless network called Omantel HQ, for example. And to access to Omantel HQ, you need to use your username and password. Now, the attacker, he don't have a username and password. However, he would create a similar wireless network having exact the same name of Omantel HQ, but on a different channel. So when a user tries to access Omantel HQ, for example, wireless, he would find two wireless. And the attacker would hope that this stuff connect to his access point instead of Omantel legitimate access point. This is one type of attack. The other type of attack, he would launch an attack called deauthentication attack, where he can intercept the traffic and force everybody to be kicked out of the legitimate access point. And when they try to connect back to that legitimate access point, they will be redirected to rogue access point, which is created by the attacker, and he would provide them with uh, a website or a portal look exactly similar to Omantel web portal, where he asks the users to enter their username and passwords to access Omantel HQ wireless. So unaware stuff, they would fall in this trap and they would give their legitimate username and passwords. After that, the attacker would send them back to the legitimate access points, telling them your username and password is wrong, try again. Then the user will try again his legitimate username and password on the legitimate network, and he will get access. And meanwhile, the attacker would capture these username and passwords, and he will access the legitimate Omantel HQ wireless network, and that's it. He's in the network. Now he can perform his attacks, and he can run a reconnaissance attack on the organization, trying to find vulnerabilities, trying to find connecting devices, and maybe he will jump from one device to another to possibly get the full control over the network. The third attack vector on any wireless network is wireless devices. You know, wireless networks are connected through access points and switches. Access points and switches from time to time, it's just similar to any other platform, any operating system, any device. From time to time, attackers or security researchers, they discover vulnerabilities, weaknesses on this wireless devices. So if the attacker found a vulnerable wireless device connecting the network, probably he would be able to hack that the device and get access freely to the network. The other issue with wireless devices, misconfiguration. We found during my career and too many assessments I did across the organizations here in Oman, I found lots of administrators, they configure the wireless devices with the wrong configuration. Maybe default passwords or some bypassing techniques can be used on that wrong configuration. The fourth attacking vector in wireless network is wireless signal. Now, as I said previously, the wireless networks can be connected to without entering the building of the organization. And if that's the case, that means this wireless network is not configured properly, because the signal of any wireless network should not go outside the building. And there are many techniques can be utilized to prevent wireless signals from going outside the building. Why we need that? To protect against ward drives attacks, where an attacker he can search for available wireless signals, and he can sniff what's going on that signal, the wireless. He sniff traffic, and through sniffing the traffic, the attacker can identify all MAC addresses connected to that wireless network, and then he can target a specific MAC address or specific device connected to that network by having his wireless, by having his MAC address. Some wrong configuration I saw a lot across multiple organizations, not only in Oman, but in many other countries, that they configure their networks to authenticate through MAC addresses, saying that every device have a unique MAC address, and by having that unique MAC address, we can authenticate the users without asking them to enter usernames and passwords, to make the authentication seamlessly and for more convenience for the users. However, by spreading and scattering your wireless signals outside the building, any attacker can sniff the traffic, and he can see these MAC addresses of users connected to your network. If your network is not requesting them to enter usernames and passwords and does not force two-factor authentication, the attacker only needs to sniff the MAC address, and he can spoof that MAC address and give it to his machine and try to connect to the network. When he reach the network access control, the network access control would check for his MAC address, and it would say, yes, your MAC address is on the whitelist, so here you go, you have access to our network. So this is a major flaw on configuring the wireless network's authentication. Public interface. As I said, public interface could be web application, a website, web portal can be accessible over the internet, or mobile application, or could be kiosk or point of sale in some supermarket or a mall, or even a hospital, university. You can find it anywhere. And it could be a third-party integration. Let's take it one by one. What is web application simply? In a public interface, here we see a website, and we can access it without knowing that most probably this website is connected to some sort of data center, either on the organization or any other organization. If you, for example, take it from a cloud provider. So if your website have a vulnerability and you were able to compromise the backend server, either for mobile application, web application, the case is same for all, for web application, mobile application, guys. If you were able to evade the security fences for that public interface. Most probably you reach the backend server, which is reside on the data center of your organization. From there, maybe you will be able to get access to the entire internal network. For physical security, why it is important? Because everything starts from physical security. You cannot say that I have security without physically securing your servers, your work environment, your stores, etc. So it's important to have proper control on physical security. You must have surveillance, you must have security guards, and the security guards, they must have the proper awareness about different social engineering and attacking techniques. HVAC systems are also very important because without securing HVAC systems, and I saw multiple cases where attackers were able to hack HVAC systems, they modify it and they turn off the ACs down, they raise the temperature of the organization, and eventually the whole data center went in a fire. Also, energy resources, and we saw in multiple cases around the world, the attack will start from cutting off the energy. If you have no energy, that means you have no digital environment. You cannot operate without having proper energy. So you must physically secure the energy resources, not only from attackers, but even from environmental issues like hurricanes, earthquake, floods, fires, etc. You must have a proper control in place, and you must cater for the environment hazards as well. Human attack surface. Human attack surface is the most important attack surface. I left it to the last point because, as wisdom say, the last before getting least. So, as I said previously, it only requires one wrong attitude from a staff to get compromised. Because simply by one employee, all security fences, all firewalls, all antiviruses can be evaded. What are the attack vectors targeting human attack surface? Let's start for social engineering. Social engineers means that when the attackers try to get either data information from an employee or somehow force or get the user interact with the attacker without knowing that this is attack. A good example of that is phishing websites. Sometimes the unaware staff, they may access phishing attack, a phishing website, thinking that this is a legitimate website and it's from our organization. Then they will start interacting either by giving them credential or uploading documents or allowing some sort of activity. Also, it could be through emails, phishing emails. And we saw that during COVID pandemic, this social engineering attack was rising massively because most of employees working from home, so they have no direct interaction with the organization, but through emails and calls. And most probably, if somebody received a call from organization saying this is your username and password, I need you to do 1, 2, 3, he would think, yeah, this is from my organization. The second attack vector is passwords. Authentication starts with passwords. And if users are using weak passwords, most probably through some sort of vulnerability, the attacker would be able to brute force attack these passwords and get it right. And through the username and password he get, he will be able to access the organization networks. Physical security error related to humans. What do we mean by that? It could be tailgated. For example, an employee going to his organization and through the gate, another human being approached him. He said, could you please let me in? I forget my access card. And out of sympathy, that employee would say, oh, I didn't see you, but let's before the organization, but okay, I can help you. He will let him in without knowing that he allowed an attacker to access the organization. And that's applicable everywhere. It could be outside the gate, it could be through having access to the network, through wireless, for example. He say, I forget my username and passwords. Could you please open the internet in my device so that employee, without knowing, he will enter his username and password into an attacker machine, and the attacker would get his username and password. The fourth element of human attack surface is failing to adhere to the corporate policies. And I saw that nobody loves cybersecurity people. They would say they are the bottleneck. They try to stop us from operate seamlessly, and they would start to find some excuses to never adhere to corporate policy. And the fifth element of human attack surface, and it applies to all other four attack vectors, is lack of awareness. Everything happened on these four elements, it's nothing but either because of lack of awareness or because of uh, irresponsible people. They just don't care. They do things they like to do without caring about the organization. Why I said human attack service is most important? Because statistics shows that 95% of security breaches happen due to human errors at the first place. So 95% is a huge percentage. So everything starts from human awareness. Also, 45% of people, they reuse their passwords again and again on different websites. They use the same password on their organization, and they use the same username and passwords on the restaurant. They use the same password on their iCloud account. They use the same password on a hotel they visit. And if one of these websites could compromise, that's mean the attacker, he compromised the same password can be accessed to the organization. 44% of the targeted attacks comes through social engineering, through emails. 24% of data breach due to unawareness. So as I said, it's not only awareness, could be awareness, and it could be responsibleness. They don't feel responsible for anything. They do just what they like. 43% of the attacks breaches from insider threats. So some mad employee, he decided to open a board for the attackers, or just insert a disk or drive to that organization environment, and the attacker get access through that mad employee. What are the lessons learned I learned personally through the 8 years career by not having proper security architecture, missing asset management, patch management, platform, all the attacking vectors we talked about earlier. What would happen? What are the risks? Simply, an exposed to the entire network, to the internet, could happen due to security architecture, for example. A malware spreading because of not having endpoint security. Uh, Having orphan assets, or you don't know that these networks, these devices connected to our network because of shadow IT, lack of threat detection, prevention because we don't have SIM, obsoleted systems because of lack of batch management. We don't have batch management process in place. Vulnerabilities, it would make it easy to hack to the organization, and vulnerabilities happen due to batch management process, bad batch management process. Traffic interception because of weak security architecture, lateral movement, data leak, lack of monitoring. All these points are a result of not having proper management for internal network attack surface. On wireless network, broken authentication, session hijacking, credential leak, hacking of internal networks, uh, traffic interception, wireless devices are nothing but because of lack of proper management for wireless uh, surface attack. And from my experience, the easiest way to hack through wireless network because of improper authentication mechanism and lack of awareness from employees. Public interfaces, not having a proper security control, security fences on your public interface might lead to exposing vulnerable systems. From those vulnerable systems, attackers can jump to your internal network. Session hijacking might happen, and by having a website vulnerable to session hijacking, that means an attacker he can use sessions of legitimate employees to access to the network, to the website, and leverage his access to having a massive access to the internal network. Credential leak could happen due to improper encryption of the or hashing for the credential during the submission phase. Traffic interception, data leak also would happen, and hacking of internal networks through vulnerable web applications, mobile application, or any element on public interface. On physical security, sabotage could happen to weak physical security, weak security mechanism for and uh, not having guards on the site. Piggyback or tailgating, as I mentioned, could be as a result of uh, improper physical security control, fire, blackout, social engineering, asset loss, hacking of high protected assets as a result. And on social engineering part, I have a small story actually during an experience from a previous organization. I was sent to visit one of that organization data center. It is uh, protected properly. It has security guards with their weapons, and they have surveillance. Everything is proper and on place. They have procedures to access. They don't allow anybody to access. You must have a permit from the organization to access. But here, what happened? I approached that organization with a permit only to access the second floor on that organization. However, the permit is written in a language that a security guard cannot read or understand. Ending up the guards asking me what the permit says, where exactly you can access. He's asking me where can I access? So I faked the permit. I said I can access everywhere on the building, and that's it. He allowed me access to all assets on that building. So having a properly educated security guards, or at least you counter that the security guards do not speak English, for example, or they do not read English, it's really important. You must write the permits in a language that can be understood by the security guards, and do not allow the attacker to translate whatever written on that permit. Well, human error is a crucial and devastating, because, as I said, by one employee, all security controls, all security fences can be evaded by just one employee. He just open an email, or he insert an infected disk or flash drive to his machine. That's it. All what it takes is a mistake by a staff to get your organization compromised. Part of human error comes blackmailing. We saw lots of employees get blackmailed due to somehow by an attacker. Phishing emails, phishing websites, misconfiguration also is a part of a human error. Data leak could happen due to human error, and wrong decisions could happen. From an experience, one organization approached me and said they got infected by a ransomware, and one of their website is infected. They want an advice what they should do. He said what we should do. Simply, you need to disconnect first your website from being accessible over the internet. They say no, but our website is accessible by customer. You should never care about customer right now. Your website is infected by a ransomware, and eventually that ransomware will be spreaded all across your organization. However, the manager in charge, he decided that no, we are not going to listen to you. The website must stay on. The customer must have access to the website. Eventually, their entire network got infected by that ransomware. This is an example of wrong decisions. I gathered 3 of very famous breach cases happened around the world, and I did a very quick case study to know the root cause behind each and every attack. First one is Stuxnet. If you have ever heard about Stuxnet, is a malicious computer worm targeted an Iranian nuclear program, and For your information, the Iranian nuclear program and Iranian facilities are very secure. They don't allow for anybody to access, but very few sciences they can access their nuclear facilities. This Stuxnet worm is targeting BLCs working on SCADA systems that control HVAC system inside the Iranian facilities. Simply, these HVAC system control the temperature and the pressure inside the Iranian nuclear facilities, and it has gigs where it shows that the temperature of the nuclear facility, how much temperature that factory have. How that worm reach the Iranian facility? Well, according to the resources, one of the scientists, he plugged in an infected uh, flash drive to one of his computers inside the facility, and through that device, the worm spread across the organization. According to Iranians, they said 14 Iranian nuclear facilities were affected by this ransomware, 20,000 devices infected. So what is the root cause? Human error. Because that scientists have lack of awareness about ransomwares, worms, and he did not have the proper awareness of not using unknown sources of flash drive he inserted to the organization. Another example of a human error, a blackout happened to Ericsson mobile services because of some administrator they forget to renew digital certificate. Because they forget to renew it, a blackout happened, and that blackout affected 32 million of people in UK alone, and if it affected 11 countries around the world. The root cause of this blackout is a human error in the first place and not having proper asset inventory. Now, through the asset inventory, the administrator, he should came to know that this certificate would be expired within, for example, 2 months, 3 months, and he would renew it before the expiration date. The last example of cyber breach happened due to social engineering. A spoofed email was sent to Toyota Corporation, and it was telling them that we are one of your partners, business partners, and we have changed our bank account, and this is the new bank account, and kindly deposit or send us the money of this bill to the new bank account. And due to the lack of awareness, those attackers, they were able to fool finance people, sourcing people, and somehow the finance people, they sent 37 million to a fake transfer account, reaching to hackers. So the root cause is here human error again in the first place, and endpoint security. Why endpoint security? Because if Toyota Corporation had proper endpoint security, that endpoint security would probably discover that this is a fake email and it has a hidden malware on it. Now we talked about attack surfaces. What are the impact of not having a proper management for those attack surface? And I did some calculation during one of my experience across some sectors here in Oman. We did a case study after implementing the proper attack surface management on that organization. Within a year of having a proper management for attack surface, we were able to achieve cost and risk avoidance, which worth more than 88 million US dollars. Where that number came from a bank account. We were able to compromise and transfer money from it. And if we were a real attackers, we could get at least 10 millions out of that account. We calculated the cost of operation disruption, and we could stop the operation or stay the operation for 8 hours continuously. We counted the legal implication, possible local authorities, fines, and GDPR. And by the way, GDPR fines are not a joke. GDPR by itself, it reached 24 millions, only GDPR fines. Because that organization had European citizens' data, and if that data got leaked, most probably they will be fined due to GDPR law. Customer satisfaction could happen due to operation disruption and dumping the data of customers. Confidential and private data disclosure could happen. 5 million records we compromise, and you can imagine if those 5 million records were offered for sale on the dark web or just spread over the internet, what would happen to that organization? Losing business relationship, because during our activities we were able to jump from that organization network to one of their partners network. That's all from my side. I hope I didn't go very fast. Now the floor is yours for any questions. I think on mute, Kara.
Let me just turn my mute off. Thank you so much. I think that was extremely interesting. I do worry. I think that perhaps if you had your way,
I didn't hear your voice, Kara. I don't know. Is it me only? Or?
Let me just check my connectivity. Oh, okay. There we go. Mohammed, can you hear me now? Let me just try that again. Maybe Mohammed will come back through. Just let me know, Mohammed, if you can hear me. If anybody has got any questions, feel free to just pop them into the questions box now, and we can probably just take a few minutes. I realize it is 7:30, but we can probably just take a couple of minutes and take a couple of questions. Let's see if Mohammed's back. Mohammed, can you hear us now? Maybe not. Suzanne, did anybody have any questions?
Yes, actually, there's one question that's just come through. So the question is, can cyber attack penetrate via cookies? We will answer
Let's see.
that just shortly, Ahmed. Once we have Mohammed on board, I think we just lost him.
Sorry, I didn't get your question. I lost the voice.
There we go. Can you hear us now?
Yes.
Okay, great. Maybe Suzanne,
Brilliant. Okay, so
you can ask the question again.
yeah, of course. The question is, can cyber attack penetrate via cookies?
Great.
So did you hear that, Mohammed? Okay. It seems like we have a bit of an audio glitch here. I don't know if it's since I turned on my camera, and I will just try and turn it off quickly. But Mohammed, I'll give it one last chance. So if you are able to hear me, the question was, is that can cyber attacks take place via cookies?
Penetrate the organization through cookies could happen by not having proper security fences for the web applications, and it could happen due to having either previously installed spyware on your device, and it could be also targeted by vulnerabilities affecting the web browsers. We saw this year's many vulnerabilities affected, for example, Safari, Chrome, and even Firefox. And through those vulnerabilities, the attacker were able to compromise not only the cookies, but they were also able to compromise the entire device installed. I hope I answered that question.
Yeah, I think so. Thanks very much.
That's perfect.
I've
Okay,
got
there's one more
I've got
question.
Okay, go ahead.
Go ahead. Go ahead, Kara.
So I think the one question that I just wanted to ask you, Mohammed, was is that, like, I understand, I mean, you've touched on the human element so much, and I know that we try and do, you know, training and awareness as much as possible. But, you know, is there any other creative ways that you've seen that have been effective in being able to just educate employees on a day-to-day basis? I think sometimes, you know, things can feel perhaps a little technical when we try and get this messaging across. What's the most effective channel that you've kind of seen insofar as being able to give employees the education that they need in order to be able to reduce the risk?
All right. To reduce the risk, there are two elements. First, let's not depend on the human awareness. I mean, you have to put all required security fences on place. Like, for example, you don't only depend on their username and password. Instead, you need to add a second element like multi-factor authentication or one-time password. You need to force him to go through a very specific channel on the network. So instead of he's go directly to the internet, he must go through isolated network and properly secured through firewalls, endpoints, and monitoring case traffic. With that being said, now let's go to the human awareness. There are many solutions can help the organization to specifically design the awareness for each and every employees according to his need. One of those examples, KnowBe4, for example, KnowBe4, it would send multiple awarenesses to employees. After that, it would send them a simulated attack. Actually, the employees wouldn't know that this is a simulated attack. If he interacted with that attack, for example, let's say phishing email, if he opened that phishing email, the solution would automatically understand that this employee has a lack of awareness in this very specific area, and it would automatically design an awareness specifically for that employee. More than that, an organization should monitor the abnormal traffic. Let's say if we found an employee accessing his account from Oman, and after 3 minutes we see that he's accessing his account from UK, that's abnormal. He cannot move from Oman to UK within 3 seconds. So after detecting this, we need to investigate it, talk to the employee, trying to figure out what's wrong. Did he share his password with somebody else? Or is he using illegitimate or unallowed VPN, for example? So this is what we can count on a human error path. However, it will still there forever. We need to keep reminding them with security practices from time to time.
Thanks, Mohammed. That's clear. Suzanne, do you want to ask any final questions and then we can wrap up?
Thank you, Mohammed. Just one more question. What makes IP cameras vulnerable to cyber attacks?
Well, each cyber attack should be followed by investigation, and the investigators must be neutral. They would go back to check what's the root cause behind this attack. If they found this type of this attack specifically happened due to wrong practices from the IT department, then they could be counter for it. However, not every attack responsibilities come on the burden of IT department. I mean, most of attacks happen because of other stuff, not necessarily from IT. So we cannot counter all attacks on the burden of IT. We need to investigate. We need to come to know what's the root cause behind it. And I would say from experiences that most of attacks happen not because the IT department, it happened because of the decision makers, higher management. Let's say, for example, an IT department informed his management that we don't have a proper patch management in place, and to have one, we need to invest on it. We need devices, we need solutions, we need consultations. But the decision maker decide, no, I'm not going to spend money on batch management, or I'm not going to spend money on data privacy, or I'm not going to spend money on risk department. So it's not necessarily start from IT.
Okay. I don't think there's any more questions that have come through. Do you have any more questions, Cara, from your end?
No, thank you. I just want to give a big thank you, and I'm not going to turn my camera back on because I think it might have just messed with some of the connectivity, but I just want to say a big thank you, Mohammed. That I think was extremely enlightening, and I guess for all of us here, now that we understand probably, you know, a little better on what the digital attack surface looks like, you know, we need to be able to take that information and apply it within our organizations and to be able to think about these things. So we really just want to say a big thank you today for your time. And yeah, we look forward to hearing from you again in the future.
Sure. Thank you very much, Cara, for the opportunity. Suzanne, thank you for all attendees for attending this session.
Brilliant. Thank you so much, everyone. Thank you, Cara, for organizing this, and Mohammed for an excellent presentation. And the meeting will now end. Thank you, everyone, for joining us.
Thank you.